Hey Geometry, here's a video on 4.4 notes. So we're talking about congruence with transformations. So two geometric figures would be congruent if and only if there is a rigid motion or composition of rigid motions. So they need to have the exact same shape, just moved around in the graph. So some examples of rigid motions would be translations or shifting on the graph, reflections, reflecting over a line of reflection, rotations, and compositions of those three. So you could translate and then reflect, or rotate and then translate. So this says to identify any congruent figures in the coordinate plane. So we are trying to figure out which one of these are congruent. There are a few that we can go with. I'm going to start with the square. That square, or I guess I'll color it in. This square, I'm going to claim is congruent to this square. How is it congruent? There's a couple of ways that you can say. You're just going to describe what transformation must occur to get from one to the other. I'm going to say it's a translation. It's shifting left, 2, and then down. So left, 2, and down 1, 2, 3, 4, 5, 6. So you're going to write the rule for that. So x, y, and then x minus 2 for left, y minus 6 for down. The next one I'm going to do in orange. I'm going to claim, let's see, F, E, G. Does this triangle have any matches? I think there's a match with this one. This length is 2 units. This length is 2 units. This length is 3 units. This length is 3 units. So I'm going to say triangle FEG is congruent to triangle LKM. How are they congruent? So what kind of transformation is happening? This one, it's reflecting over the x-axis. Finally, I'll say, let's see, this triangle and this triangle. That's 2 units, 2 units. Same thing over here. So triangle IHJ is congruent to triangle TSU. How do we know that? There's a couple of different ways. To me, it looks like it is rotated 180 degrees. About the origin. Another name for a rigid motion or a combination of rigid motions, so compositions, would be a congruence transformation. We've got some more examples down below. Okay, so it says to describe a congruence transformation that maps A, B, C, D to E, F, G, H. So this one to this one. It could be more than one motion. So it says we could have a reflection and a rotation, or a translation and a reflection. This one looks like there's a couple of ways that we could go about it. I can see that it's reflecting over the y-axis. So the first one I'm going to say is a reflection over the y-axis. If I were to do that, my in-between point would be here. From here, it looks like it's moving down. So that would be a translation down how many units? 1, 2, 3, 4 units. So I would write that as x, y. It doesn't move left or right at all, so x stays the same, but we'll have y minus 4. For the next one, they're wondering what takes JKL to get to PNM, or MNP. Let's see, this one, it looks like it reflects over the x-axis. If I were to reflect over the x-axis, that's 2 away. 2 away, I would have points here, which looks very similar to what we have, but now we've got to move it to the right. So my second transformation is going to be to translate. To go right, I'll have x plus a certain amount. Let's see, 1, 2, 3, 4, 5. But it doesn't move up or down at all, so I leave y the same. You guys have a few homework assignments to work on. Good luck.